Today we'll be reviewing Howard Gardner's theory of multiple intelligences. Today's presentation will cover several related topics, including the multiple intelligences learning theory proposed by Howard Gardner. We'll identify these distinct intelligences, and then the intelligences will be defined and aligned with learning. Next, we'll look at some commonly seen intelligences in a computer science classroom, and last, we'll note evidence of alternate theories seen in these classes. The theory of multiple intelligences was developed in 1983 by Dr. Howard Gardner, a professor of education at Harvard University. He presented the theory for the first time in 1983 in the book Frames of Mind: The Theory of Multiple Intelligences. He felt that the traditional notion of intelligence based on IQ testing is far too limited. Dr. Gardner proposed 8 different intelligences to account for a broader range of human potential in children and adults. Here's a commonly seen representation of Gardner's theory of multiple intelligences. First, we see musical intelligences, or music smarts, bodily kinesthetic, or body smart, interpersonal intelligence, or people smart, verbal and linguistic intelligence, which is word smart, logical mathematical intelligence, commonly numbers, logic, and reasoning smart, naturalistic intelligence, or nature smart, interpersonal intelligence, self smart, and visual spatial intelligence, or picture smart. Not shown in this common diagram is the 9th intelligence, existential or big picture viewpoints. The next few slides will give a bit more insight into each of these intelligences. Verbal linguistic students like to read, write, tell stories, and do puzzles. Traditional teaching methods often work for them. Math logic students enjoy working with numbers and solving problems. They enjoy the challenge of more complex problem solving. The visual spatial students like to design and draw, visualize results, and work with images as part of the learning process. Bodily kinesthetic students tend to be our athletes and dancers who are into more active assignments. Musical students are in band and choir. They like to work with sound and rhythm-oriented features of our programs. Students with interpersonal intelligence show a social aptitude which manifests in group work and discussions. Intrapersonal students like to work alone at their own pace to complete tasks their own way. Naturalistic oriented students tend to like nature and natural events. And then there's the 9th intelligence, existential, which was later added to the theory by Gardner. These are the big picture thinkers with a worldview and social impact concern. They like to see the overall plan before starting projects and may offer alternate viewpoints during discussions. Next, we'll see how some of these intelligences manifest in a computer science classroom. As we look at multiple intelligences in a computer science classroom, we can identify the target learners as public high school computer science students in grades 10, 11, and 12. Student academic abilities are a known factor. Multiple intelligences may be identified by students' involvement in extracurricular activities, and many students are involved in AP classes, athletics, band, choir, debate, foreign language clubs, and graphic design courses. Most display a capacity for more than one intelligence. Lessons and special projects can incorporate varied student intelligences. I typically observe logic and mathematic reasoning skills, and when given the choice of a topic or interest for app design, it often correlates to their intelligences. Additional intelligences are challenged using classroom presentations and app design posters. Then there's always opportunities for independent work as well as group work that show those intelligences. We do see alternate theories evident in the computer science classroom. Although constructivist, the development of higher order thinking skills is crucial in computer science. We lean on a cognitivist theory when information is chunked to prevent overload and use it as a scaffolding strategy. And common to brain-based learning, the class offers an environment of relaxed alertness, immersion, and active processing of this technical material. We recognize and enable students that learn different ways chunk content and allow our routine schedule that allows time for activities. Today's presentation covered the multiple intelligences learning theory proposed by Howard Gardner. We identified these distinct intelligences, and then we saw how they were defined and aligned with learning. We then looked at some commonly seen intelligences in a computer science classroom, and last, we noted evidence of alternate theories seen in computer science classes. We've provided references for our information provided today, and would like to thank you for viewing our presentation.